Hi guys, NCWQ here, and this is another article, Science Behind California's Two Biggest Earthquakes, and this is by National Geographic. And the article goes on to state, the pair of powerful temblors that shook the United States West Coast promise fresh clues about region's complex geology. On the morning of July 4th, a magnitude 6.4 rocked Southern California, fracturing roads and sending people fleeing to safety. But that wasn't all the Earth had in store. Less than a day and a half later, a powerful magnitude 7.1 tremor shook the region. While earthquakes are not unexpected, the two most recent tremors are the largest that have struck this area in decades, and they promise to yield fresh clues about its complex geology. The duo of quakes struck in what's known as the Eastern California Shear Zone, an area east of the infamous San Andreas Fault, where the Pacific Plate grinds against the North American Plate, creeping northwest at roughly 2 inches each year. The area extends from the southern Mojave Desert up the eastern side of Sierra Nevada and into western Nevada. It's crisscrossed by fractures in the earth caused by movement along its nearby tectonic plate boundary. The Eastern California Shear Zone is a really interesting area, says Wendy Bohan, an earthquake geologist at the Incorporated Research Institute for Seismology, which is IRIS. How is it working? How is it accommodating plate motion? What are going to be the big structures that come out of this millions of years down the road? Well, what happened? The recent events are known as what's known as strike slip earthquakes, which occur when two blocks of earth slide shifts side by side, grinding past each other. They seem to have occurred along the same set of faults located in an area known as Little Lake Fault Zone. While no deaths or major injuries have yet been reported, the intensity of the ground movement was quite strong, enough to send goods flying off store shelves and breaking buildings swaying. The shaking was also widespread with reports of light ground movements as far as Chico, California, and Phoenix, Arizona. Of particular interest in these quakes is that at least the first tremor seemed to have simultaneously broken two sections of the faults that cut across each other at nearly a right angle. While such complex quakes are not unheard of, recent research suggests that they may be more common than once believed, explains Zachary Ross, a geophysicist at the California Institute of Technology. Historically, the thought has been that earthquakes occurred on the individual faults, he says. And then over time, as the data has gotten better and better, we've started to realize that there's potential for multiple faults to rupture for single events. This shift in thinking was propelled by the magnitude 7.3 earthquake that shook Landers, California in 1992. This tremor fractured along at least 5 fault segments. Subsequent earthquakes have revealed similar complex breakage, including the 7.2 earthquake in 2010 in Baja California, Ross notes. This latest earthquake is further evidence that this complexity is common even for smaller magnitude events. So, why did two big earthquakes strike? In circumstances, big earthquakes strike in a familiar sequence. There's a large earthquake followed by a series of smaller events. That's because the movement that occurs during the large earthquake causes increased strain in the surrounding region. Earthquakes are the Earth's way of relieving the strain. But in some circumstances, such as the recent pair of earthquakes in California, a relatively large tremor might be just the forerunner for even bigger event. While the difference between 7.1 and 6.4 may seem minor, magnitude is logarithmic scale. An increase of a unit of magnitude is about 32 times more energy, which means that the second earthquake released roughly 11 times the energy of the first tremor. Scientists think of this series of earthquakes as the foreshock, the main shock or strongest event, and then the aftershocks, explains Susan Hugh, a seismologist with the U.S. Geological Survey. But it's way too simplistic, she notes. Every earthquake causes a shift in the landscape, redistributing the strain in the crust, which means all the earthquakes could trigger other earthquakes. Whether or not an earthquake itself is an aftershock, she says, you can think of it as a potential earthquake parent. The likelihood that a big earthquake will trigger a larger event is roughly 1 in 20, according to Hugh. That's definitely a low risk. But that 1 in 20 isn't zero, she says. Scientists, however, are still untangling the connection between the recent events. The magnitude 7.1 trembler seemed to break along the northwest southeast limb of the pair of faults that ruptured earlier, Hugh notes, extending farther from the first quake in both directions. Major scientific questions. Did part of the fault break and then break again? How did breaks compare in detail? She writes on Twitter. Finding the answer to these questions could have important implications for understanding the hazards of these events. This appears to be the clearest case I've seen that did indeed happen, she says, of the same fault rupturing more than once in a short period of time. But much more work is needed to sort out the details. So, what's going to happen next? So far, many more than 1,000 aftershocks have rippled through the region. While the frequency and intensity of subsequent tremblers will wane, Southern California likely has more shaking in store, and magnitude 7 is going to produce activity for years, Ross says. The USGS estimates that over the course of the next week, between 240 and 410 earthquakes of magnitude 3 or higher will likely ripple through the region. These are events just large enough to feel if you are positioned close to their epicenter. As for larger earthquakes, the probability becomes increasingly small, but not out of the question. The USGS estimates that there's a 24% chance that as many as 2 earthquakes magnitude 6 or larger could strike in the next week, but as scientists continue to analyze these events, they may adjust those numbers. Such a strong series of aftershocks is not unexpected. Earthquakes out in the Mojave Desert traditionally have these bigger, robust aftershock sequences, Bohan says. She cautions, however, that all of these probabilities are forecasts and not predictions. No one, despite what some claim, can predict future earthquakes. She likens the difference to weather forecasts, which are an estimate of the probability that something might happen. You would never predict the weather, she says. You can't predict with 100% certainty that it will be raining unless it's raining, and earthquakes are very similar. Rohan emphasizes that it's normal to be scared during an earthquake, which can rock the ground like a boat in rough water. But as aftershocks ricochet through Southern California, she suggests that people who live in earthquake-prone regions check how prepared they are for the next event. This was a good scenario earthquake, says Bohan. It was in a fairly unpopulated area, but a lot of people felt it. Bohan hopes that means those who experienced it are getting ready for the next one. It's okay to be scared, she says, but we also have to be prepared. Anyways, you guys, hope y'all are having a great day or night wherever you are in the world. Please like, subscribe, and share. Much love and have a great day.